Hello and welcome to another video by me, Zaphod Beeblebrox, for the Brit Tech Guru channel, or British Tech Guru channel. I have been working hard on the accelerometer. Here we go. See the accelerometer sticking out of the board there? That is actually behind one of my most interesting challenges. I started off by coding the accelerometer software. That took me a long time to get that working correctly. It was rather frustrating, to be honest. Anyway, eventually I got the accelerometer to read. Then I found, having read it, I was getting some really rather strange values, to be honest. And I was expecting angles of motion, like 10 degrees, 20 degrees. No, wasn't happening. Okay. So I hunt around, because of course I'm not used to using an accelerometer, and I really wanted something to measure in angles rather than in g-forces, which is what it seems to measure in. The nearest thing that will measure an angle is a tilt switch. Or something called an inclinometer, but I have yet to see inclinometer components available cheaply online, and the cheapest I saw was about $50, or might have been more than that, might have been $100, and I'm not prepared to spend that much money on that right now. And heck, the components that I'm putting together for this drone controller are going to cost something like probably $75, and I'm trying to do this inexpensively, so I'm not going to buy specialist components. Well, I will buy specialist components, but I won't buy expensive specialist components. So having worked out that there is a problem with reading and applying the data directly, I did some hunting around, and I found there was something called a Kalman equation. Now, I'd never heard of that before, and I had a good look. I found a frightfully complicated looking MIT lecture, no, sorry, not MIT, Stanford lecture on that subject. I read the PDFs, or rather I looked at the pictures on the PDFs and looked at the equations on the PDFs and thought they were somewhat frightening. And bear in mind, I last did calculus 30 years ago when I was in college. That is rather a long time to try to remember differentiation and integration. So I said, okay, let me look at this differently. So I had a look around, and oddly enough I found some software on GitHub that had the equations neatly done in a C++ program. Well, I'm not programming in C++, I'm programming in Python. Okay. So what do I do about that? Well, that was actually quite straightforward. I just went through the C++ code, found the equations, copied them into Python, changed them around where I needed, imported the math library, done. And then I tested it. I had a lot of fun testing it. I found that I was getting really wacky results, absolutely wacky results. Then I found out why I was getting wacky results. Two reasons. Number one, the overwrite on the screen thing with Python doesn't work all that well, so I can ignore that. So I was getting things like 80,000 degrees. No, doesn't work like that. Anyway, and then I found that the Y and the Z axes, they just, one worked nicely, the other one didn't work at all. What else going on there? Then I remembered. You see, I've got that chip, that board. Yeah, it shouldn't be sticking up like that, or rather it can be, but it's going to be reading like that. So it's going to be reading like that, or like that. What it's actually measuring is probably the X and Z axis rather than the Y axis. So I have to turn it round, and then it all made sense. Let me show you. Okay, so let's get rid of that. Okay, here we are. Here is the program. This is the basic setup, including math. This bit here is totally redundant for the moment, but I left it there. And here we are. Here are the guts. That just addresses the accelerometer. This reads the X and Y axis of the accelerometer. Why I've got the Z in there, I'm not entirely sure, because it was not part of the equation. And here are the two equations. Now these were a lot of fun, converting from C++ into Python. And they oh, hang on, have I got Z? Yes, I've got Z in there. Yes, I've got it all included. Yes, that works. That's perfect. So it prints out pitch and roll. So let's see how this all works. And what surprises me is that I haven't got the other part of it. Oh gosh, the accelerometer in there. It's just got the gyroscope. No, sorry, it's got the accelerometer, but not the gyroscope. Okay, I'll keep taking the pills and I'll get better one day. Anyway, let's run this. So, oh, division by zero error. Yes, that is one of the things that happens, because there is actually a bug in the code. I downloaded this code from, well, the initial bit of this code from GitHub. So let's get rid of that. Start again. There we go. Right. Now, if you notice, roll is very, very shallow, and it's not changing. So if I turn this the correct way, then roll moves nicely as I move the accelerometer, and I'm moving it up and down. And then if I move it in pitch, see how the pitch is increasing and decreasing and going negative. So yes, I've got that code working. I'll stop that now. So as you can see, that all works nicely. Once I had all the problems worked out, it all worked pretty straightforwardly. I'll admit I did look the code up for the equations, because I really did not feel like dragging out the math books and working my way through Kalman formulae. Why, when somebody else has already done it? So I'm reasonably happy with that part of the thing at the moment, that part of the drone at the moment. The next part will be to add a barometric pressure sensor. I have a barometric pressure sensor, if only I knew where the bloody thing is. I've put it down somewhere. I know you've seen the size of this accelerometer. Compare that to the size of my finger. See how small it is? The barometric pressure sensor is half that size. And I know I've seen it recently. I just can't find it. It could be stuck to the back of something for all I know. And it could have fallen into a cardboard box and got stuck underneath a flap. I don't know. Frustrating, so I've had to order another one. That'll be here in a few days. So, I've got my accelerometer working for the purpose for which it was purchased, for giving me pitch and roll. I don't need yaw, because yaw will be provided by my GPS device, which I have yet to employ. Now, this accelerometer was a challenge because that was the first I2C device I've ever used. The pressure sensor was the first I2C device. I didn't realize it was I2C when I used it. So I'll get another I2C device, which is the barometric pressure sensor, and the GPS device is yet another I2C device, which is great because all of those three things are I2C, which means they all run off the same two wires, which means I have all the other GPIO wires left to operate things like servos and the propulsion motors. So I'm quite happy there. Really happy, in fact. Maybe too happy. Anyway, so that's all I've got for you today. And we'll probably meet again in the next video. And as always, my name is Zaphod Beeblebrox, and this is the British Tech Guru channel. Oh yes, and I do ask questions all over the place. Occasionally they seem silly in retrospect, but at the time they weren't. So if you find some of my questions, they're quite simple, like, how does this device work? You'll find that quite a bit. And that's just me trying to get information, trying to understand something before I get into it. Now this, I got into, asked the questions, and understood. That's how I work. Anyway, and as I said before, see you in the next video.